Hello all, welcome to the video lecture series for the subject operating system. Now it is a continuous topic of the page replacement algorithm. The name of the algorithm is optimal replacement algorithm. So we are going to check how effectively this optimal replacement algorithm actually works. So basically what is this optimal replacement algorithm is the pages here are replaced which would not be in use for a longest duration of time in future. That is right side. We are going to check in the right side. In future, any of this requested frame from the CPU is not used, right? So let's get into the topic directly, and we are going to check that one by one how this reference string has been made. I told you already this reference string is requested by the CPU, that is 7012. These are all in the queue. These are all the frames, and initially all the frames are in empty state, right? For easy understanding, I made this into empty initially, and one by one how this requested string from the CPU is taking inside its original places. The first request is 7, and 7 is not available in this frame, so it is a miss. So I'm going to mention it is a miss. We are going to calculate how many number of miss and hits is there. So one by one we are going to check. So 7 is taking the first frame, and next frame 7 is already there. So next requested is 0. First frame is already filled with 7. So 0 is taking the next frame, and 0 is a miss here. It's a miss. The next requested by CPU is 1. 7 is already there. 0 is in second frame, and the third frame is empty. So this 1 is brought into this particular third frame. This is also a miss. Whenever CPU calls, and if it is not available inside this frame, then it is a miss. If it is inside the frame, then it is a hit. So now we are going to check that. Now 2 is coming inside and the frame is full, right? This is the problem. And how does this optimal replacement algorithm works, and which particular string will be replaced and which frame is replaced here. Now 2 is coming inside, and we are going to check in 701 whichever is not used next recently in future. So you can go into check that. So 7 you can check one by one, it is not used. 0, it is used recently in future. 1, it is absolutely used recently in future. So 7 is not used recently in future. So I'm going to replace this 7 and bring this 2 inside, because it is requested by the CPU, which is very necessary. So 7 is replaced. 2, 0, 1. So 2 is not inside, so it is also a miss. I hope you understand how it exactly works. Now next request by CPU is 0. So 0 is already inside, so it is a hit. It's a hit. Now 3 is called, the next bit is 3, which is called by the requested by the CPU, and 3 is not inside, so it is absolutely a miss. Now let's check which particular thing will be replaced. See here, I told you we are going to check the future, that is which is not used in future. So which bit? 2 I am going to check it. So 2 is used in future. 0 I am going to check this. 0 is used actually very next, and 1 I am going to check, and 1 is at the last. But even though comparing to 2 and 0, 1 is used at the last. So next seniority is given to 0, and 0 is next used after this 3, and 2 is not used. Okay, so comparing to 0, 2, 2 and 1 is not used recently in future. I hope you understood, right? So I'm going to replace this 3 with this 1. So let me, so 0, yeah, it is replaced here. So that's a identification mark. 2, 0 and 1 has been replaced into 3. So here it is here. So this 1 has been replaced into 3. Now 0 is coming inside. 0 is already there, so we are not going to disturb this 0. So definitely 2, 0, 3. Whenever 0 is called, it is already inside, then it is a hit. I hope you understand now. So let's see what this 4 is doing and which particular process is replaced. 4 is coming inside, and it is going to check. See here, 203 is there. Okay, so 203 is not used future, not used in future. So 2 is used very next, and 3 is also used after this particular 2, and 0 is used next. So comparing to the seniority of this 2, 3 and 0, you can replace that 0 here. So 2 is not replaced and 0 is replaced because it is most not used in future for a longest period of time. So 2 is used again, 3 is also used. After the 3, 0 is coming. So 0 is not used in future comparing to 2 and 3. Anyway, it is used in future, but after 2 and 3 it is used. So the 0 can be replaced not with 2 and 3. I hope you guys understood this. So 0 will be replaced by 4 and 3 is already there. So 0 is replaced here, right? So it is a miss. So now 2 is called here. 2 is already inside. So it is a hit. 2, 4, 3. So it is a hit. Now the next frame is 3. 3 is called here. 3 is already inside. So it is a hit. 3 is called already. So it is a hit. Now we are going to check that 0 is called here. There is no 0 available in this frame. So it is a miss. Definitely it is a miss. Now we are going to check that which particular frame and string will be replaced here. That is a page will be replaced here. Now 2 is there, 4 is there, 3 is there. Now we are going to check that in future. Which frame or sorry, which string or page is not used in future. So 3 is used here in future and 1 is not there, least bother. 2 is next and 0. So now which particular process will be replaced here? 4 is not used in future. So this 0 will take the place of 4. See here 2 is also used in future, 3 is also used in future. So 4 is not used in future. So 2, 0, 3. So the replaced one is 4. Right? Again 3 is called here, 3 is already inside. So it is a hit. So 2, 0, 3. If something is hit, we are not going to replace anything, right? So it is a hit. Now 1 is called here. Which one has to be replaced? You can check it. Now in future when 1 is coming, 2 is there already, 0 is already also there already. So which is not there comparing to this page number 2, 0 and 3? 3 is not there in future. That's a point. So 2, 0, 1. That means page number 3 has been replaced. You can call it as a page or a string, no issues. Now next thing is, so it is a hit, miss, right? It's a miss. So 1 is not inside, so it's a miss. So 2 is called inside, 2 is already in this frame. So 2 is a hit. 2, 0, 1. It's a hit. So 0 is called and it is already inside this frame. We are not replacing anything. So 2, 0, 1. It's a hit. Let's calculate how many number of hits here. So 1, 2, 3, 4, 5, 6, 7. So we have 7 hits here. So page hit is equal to 7. So let's calculate how many number of page fault. Page fault is equal to number of misses called as page fault. 1, 2, 3, 4, 5, 6, 7, 8. So totally 8. So we have 15 strings here, right? So we have totally 8 page faults, right? Let's calculate. Say for example, you can calculate this by using the formula. So let's calculate page hit is equal to number of hits divided by reference string requested by the CPU. So what is number of hits? 7 divided by request string is 15 into 100. That is the answer for this. What is the page fault? The same formula has been used. This is page fault. Page fault is equal to number of fault, right? So when number of fault is compared here, the reference string will be divided with it. So number of page fault, you know that already. The answer is 8 divided by 15 into 100, right? So this is how this page fault algorithm works. That is optimal replacement algorithm. I hope you understand the video. Thank you.